So in this first screencast, I want to give you a short introduction about the internals of Git and how the data that Git managed is stored. So for this purpose, I want to create a small repository and just put some files in. So just create a README file and maybe let's actually create a folder and maybe also inside another file. So now we have that data, and then just add this and commit it. So what we actually did now is we created a repository and added two files on one subfolder, and I want to show you now how this is stored in Git. So as you might already know, using Git for a longer time, there is always that hidden .git directory, which holds all the state and the database that Git has. And as you can see inside, there is a bunch of stuff going on, but the only actual interesting thing for us now is that objects directory. And we can also have a look inside here. And actually, just let me do it like this. So as Git works for commits with SHA-1 hashes, the same is true for the objects. So inside of that directory, there are actually some plain text files, which are the actual objects that Git stores. And these are, in theory, plain text objects. The reason, though, that we cannot just inspect them by using cat or less is that they are setlib compressed. But thankfully, Git has own comment for this, which is cat-file, which accepts multiple parameters. And for P, we will pretty print the object contents. So we can have a look what it actually inside there. And as you might also see, these files are grouped into directories, and the first of the two characters, which represent the directory here, are actually also the first two characters of the actual SHA-1 hash, but they're just splitted to not have so many files in one directory, and the rest of the hash is just the end, which is the actual file. So we can use the whole hash without the slash inside and just inspect it by that git cat file command. And as you see, this gives us the content of the file that we actually created before. And this is called a blob object, which we can also see if we use the -t, which will give us the object type instead of the contents. And a blob is a file that stores the contents of our files under version control. But this is not the only information that Git needs to know, so there's actually more. Just have to find out which one actually is something different than a commit. So I'll just have a look. Maybe this one is of a different type. Okay, so here we have a tree, and a tree is responsible for saving where data belongs in which directory it's saved and what the name is. So if we print this, you will see that this gives us actually the tree object of the root directory of our repository. And inside you can see that there is one file in that directory that's called the readme.md, which has its own SHA hash. This is actually the same hash that we have somewhere up here. I think this one. And the second one is a tree object like this one, but we have a subfolder inside, so this is not saved as a blob, but rather as another tree. This also has some hash referenced here, so this is that A3. So what Git actually does when you create a commit is that it creates the blob objects for files that have changed or were added newly to the repository, and then builds a tree object for the path that has changed, or for the multiple paths that changed. And this is the way it stores data. So we can actually have a look what we have inside that subdirectory here. And you will see that this is the foo file that we have. But as you see, we have 1. So that root directory, this is 1, and this has 1, folders 2, 3, and 4, but actually we have 5 entries here. And this is because the commit itself is also stored as an object inside this directory. So we can have a look which one this probably is. I think the 5e, we didn't have this before. So let's just inspect the type first. Whoops. Yeah. And this is the commit object that was actually written after the blobs in the tree was written. And when we inspect the contents of this, you can see that this gives us the information that we actually had when committing that stuff. So we have our tree object referenced, which is this one. So the root directory of the whole repository, as it was at the point when this commit was created. Then we have author and committer, which is some metadata for the commit, and we have our commit message. So actually, this is how Git stores that data internally. So we have plop, tree, and commit as types, but actually there's a fourth one, which is the annotated tag. As you might also already know, is that tags are somehow aliases for that SHA-1 hashes, so that you don't have to remember like this one, which is the SHA-1 hash for the first commit we made. We could actually just define an alias in form of a tag that points to this commit, and we can do it like git tag, and then we could pass the sorry, not the reference, but actually this will be done on the head by default. So we can use, I don't know, 1.0, which is our initial version, the stuff we are currently working on. But this actually would not create a tag object. Actually, just let me show this to you. So when I create this tag and we have a look inside that object directory, we have exactly the same amount of files that we had before. So that tag object is actually stored in the refs directory. So when we have a look here, there's also a refs directory, which, as the name says, holds the references to other objects. So we can go to that directory as well. And you see that we have heads and tags. So let's go inside tags here. And you see that there's a file called 1.0, which is exactly the name of our tag. And this actually really is a plain text file, which is not even compressed. So we can have a look at it. And this is exactly the hash of the commit that we inspected before here. So this is what is in Git called a lightweight tag, because this does not create an extra object, but just references to a specific commit. And now let's just create annotated tag, which then will create a ref and additionally also a tag object holding additional metadata. When we set a tag, we actually have also to set some message like for a commit. So this is a annotated tag. And when we look now, again, we have also that version 1.0.0. And if we inspect this, this does not point to one of the commits or one of the objects we have here, but to a new object. And when we go back to our objects and have a look again, we can see that we have now one object more. And when we inspect this with git cat file-t to get the type, excuse me, what the hell I'm doing here, git cat file-t, like this. You can see that this is our fourth object type, which is the tag. And if we inspect the contents, you can see that this almost looks like the commit object before, but actually this points to type commit, and this is the commit object we had before. We have the name for our tag, we have the name of the tagger, and also the commit message that we specified for this tag. So these are the four types, and this is I think, already it. So if you want to create a repository, or if you want to create commits, you could actually just go ahead and create files like this inside the objects directory. And if you compress them correctly and do everything, then Git will actually accept this and will show stuff like this in the history. And with this, this is it for now. And I will see you in the next screencast.